The student learning outcomes for natural science roughly align with a three-dimensional model of student understanding. First, what do our students know? Second, how are students thinking and reasoning? And third, what is it that our students can do? We've taken this model of three-dimensional understanding as the theoretical framework on which we have built our assessment strategy. When students have completed our courses, what new content knowledge do they possess? What new science abilities have they acquired? Has their thinking and process become more sophisticated? We decided that our first big dive into assessing student learning in our classrooms should be in the general education courses impacting science majors. These courses are the first semester algebra-based physics and calculus-based physics courses, and the accompanying lab course. Going back to our three-dimensional model, we chose research-verified assessment instruments that covered each component. For content knowledge, we chose the Force Concept Inventory, or FCI. This assessment tool is used in physics programs all over the world and assesses content knowledge and forces and motion. For science abilities, we have joined with the Cornell University Physics Education Research Group to help validate the Physics Lab Inventory of Critical Thinking, or PLIC. The PLIC is designed to assess students critically evaluate experimental methods, data, and models. Finally, the Physics Education Research Group at UNO developed the Omaha Assessment of Process and Problem Solving, or OAPPS. This instrument is a research-validated rubric that assesses students' problem-solving process within the context of physics. Our goals for the first stages of the development of our assessment plan are as follows. We want to choose assessments and strategies that are easy for the instructor, easy for the assessment coordinator, and that can be administered with as little disruption to instructional time as possible. The FCI and the PLIC were administered completely online both before and after the course. Instructors supplied the coordinator with an email roster at the beginning of the semester, and the coordinator used two different third-party systems to deploy the assessment surveys. The OAPPS is a rubric used to grade student work solving problems in the course. We found significant issues with the deployment and analysis of the OAPPS as a uniform assessment instrument. Although the rubric has high measured reliability and has undergone extensive validity measures, it is also rigid in its approach to a specific pedagogy and costly to administer. These concerns led us to believe that the assessment is not a long-term sustainable option due to the cost, instructor time, and specific pedagogical issues encountered. Our online assessments achieved pre-course response rates of approximately 30% on average. However, our post-course response rates were significantly lower at 15%. There was still work to do on improving response rates. We are currently investigating a uniform distribution system with course and instructor personalized emails. Using the FCI, we measured student proficiency in motion and force both before and after instruction. Our 60% post-course target is based on the research literature. We can also use the FCI as a measure of instructional efficacy by measuring Cohen's d effect size. We've set a target of a medium effect size. It's important to also look at effect size, since research shows that pre-scores can have a dramatic effect on post-scores. This means that it's possible instruction is top-notch even without proficiency targets being met. The data collected in the spring of 2019 shows that we have some work to do in the Physics 1110 course. However, we have to keep in mind our very low response rates during this period, which can lead to unreliable results. Finally, the PLIC was administered in two different types of lab courses in spring 2019. First, a reformed lab where we are running as a pilot, and second, the lab course as it has been run for many years. The pre-course results in the PLIC were similar for both groups, but the reformed course saw significantly higher shifts in score compared to similar courses at similar universities. Both sections met the proficiency target that we defined. These measures will help our department improve by pointing us in the right direction and providing data for decision making. You can't improve what you don't measure.